All right, here we are. Hey, look at this. This is Happy Little APIs Season 2. Look at who I have now. Ryan, I've been practicing. Ryan. Did I get it right?
Yeah, Ran.
Oh, Ryan. Okay, so this is, and it's a ribbon zaft. Okay, so this is my guest, Ran Ribbenzaft. He is one of our serverless heroes. So excited to have you on with us. He's also the one of the co-founders and CTO. Is that correct? Of Epsagon.
Yes.
Good, because that's what's on the screen. Because if I'm wrong, then lie for me. That'd be great. So, and today we're here. I'm glad you're here joining us today. We're here talking about Happy Little APIs. And I hope you're happy about that because we are. Rand, tell us a little bit about you, and then we'll kind of jump into what we're going to be doing today.
Perfect. So as you mentioned, I'm an AWS serverless hero. I'm also the co-founder and CTO at Epsagon. In my background, I did a lot of R&D. I'm fascinated about microservices, serverless, compute in general. That's fascinates me. Every new feature, every new toggle that comes in, and super excited. I love live coding. I hope that I won't mess up this one, but definitely if you're listening and you can help while I'm doing the live coding and live setup, please go ahead and help me. But that's it. Super excited, except for that.
All right. Well, like I said, I'm excited to have you all here. I am running the stream as well. So this is the second time doing that. So, all mistakes are mine. This is how we're doing it. We're both in our houses. I am not in New York City. You can see I've got New York City behind me. That is because I love New York City and just, support for those that are going on there. So that's my ode to them and to my boss, Chris Munns, who's a New Yorker. So, Rand, tell us where you're coming from.
I'm based in Tel Aviv, in Israel. Things here, I think, a bit more chilled, but still as the same, the rest of the world, everybody's panicking to buy toilet papers and, alcohol gels and things like that.
I understand that. Well, stay safe, stay healthy. So, all right. So here's what we're going to be doing today. Let's go back to our slides here, and we're going to be talking about. Like you can see, we're going to be talking about Happy Little APIs. Today, we're going to be talking about HTTP APIs. Now, I covered it a little bit in a webinar a while back. We talked about doing private integrations, and so we're going to get get into that some more. So, when we talk about private integrations, let's see if I can get my screen to advance here. There we go. Why would we use a private integration? Well, I'm a serverless guy, and we talk serverless, and that's usually what I'm talking about. I'm the serverless for everyone guy. But sometimes, Rand, prepare yourself. Sometimes architecture is not serverless. Sometimes it needs to be something like containers. Yes, they're real world architectures, and they're good architectures. They have their place, and sometimes we want to be able to get to that kind of thing. So. What we're going to be talking about today is instances like maybe EC2 instances or Elastic Container Service or EKS, and how can we put HTTP API in front of those? And the fun thing is announced with GA and HTTP API, we're able to do several. And I'm going to pause real quick. I'm going to give a shout out to my team, the DAs. Some of them are on here. They're going to be doing some moderation. So if you have questions, throw them in the chat. I'll try to answer them. But as you know, I'm running. I have 2 fingers, and I'm running something that needs like 27 fingers. So I'm jumping around. So these guys are going to be answering questions and helping us out. So thanks to the DA team for being in here. And so again, if you have questions, post them, and we'll answer them as best we can. All right, so back to our story here. So
Great.
you have stuff like, again, ECS clusters, EKS clusters, and we want to be able to connect to them. And with HTTP API in GA, we added the ability to do private integrations. And we're able to do it a couple of ways. First of all, you're able to do it through a network load balancer. Okay, now that's something you're able to do with the REST API as well, and this allows you to. This is a level 4 load balancer. Allows you to do. You can give it a direct API or IP address, things like that. However, with HTTP API, we also add the ability to do it with ALB, so an application load balancer. This is a level 7 layer, or layer 7, level 7, layer 7. Sounds like a video game, doesn't it? Layer 7 load balancer. And so this gives you some more power where you can do things like, header-based routing or path-based routing. And Rand, jump in if I'm missing something, but that's kind of, ALB is kind of a norm for containers, right?
Yeah.
Okay.
Yeah, definitely.
Okay. Yeah, and for those reasons, and so we have a lot of customers who are using application load balancers for their containers, but they want the extra features that are added with the API gateway. Another
benefit of the application load balancer is that you can stream it directly to a Lambda function. So if you're starting to pull out endpoints or APIs into serverless, that's very easy integration that comes out of the box.
That's absolutely right. Yeah, exactly. Yeah, so that's a great place to start as well. So now, the last thing that we're doing is with AWS Cloud Map. And if you're not familiar with Cloud Map, Cloud Map's pretty cool. Rand and I were talking about this earlier, but Cloud Map gives you the ability. It's a service discovery service. Service discovery. So let's go resource discovery service. Maybe that's a better way to say it. And it allows you to say, I create a namespace, and we're going to demonstrate this, so I'm not going to go too far into it, but I create a namespace. Under that, I can create services, and I can have multiple services. And a namespace is like tied to an application, right? So Rand, you built and from what I understand, you built some kind of surprise application. Is that correct? You haven't told me what the application is.
It's super secret.
Okay, so which makes me a little nervous, I'm not going to lie to you. So we'll see what happens. This very well could be Rand's last time on Happy Little APIs. We will see. It could also be my last time on the air. We don't know. So stay with us. We'll see what happens there. So with that, you're able to, you can say, I'm going to have a service that might be my backend, or it might be a client or something like that. And I can have services. Then each service has resource registry. And with this, you have to use the serve registry. You can't use an A record, but you use an SRV. And you're able to say, okay, this service has these ECS clusters or these EC2 instances, different things like that. We'll get more into that. I'm probably over-explaining at the moment, which is, my kids will tell you that's my gift. I'm a lecturer. There it is. So, all right. So let's see here. This is the actual architecture of what we're going to build. Okay. So if you look at this, we're going to take, you have HTTP API. We're going to show you how to do an NLB and an ALB and a cloud map, or we're going to get to them, as much of them as we can. And then we're going to put that in front of an ECS cluster that actually sees the Amazon EC2 instances as its resource. Did I get that right, Ren?
Yes.
Okay, good.
That's
all right.
Exactly
no
it.
changes. It would scare me if you went, no, that's not what we're doing at all. The other thing we're going to do is show this, is we're going to show how to secure that connectivity on the backside. Okay, and so you're able to use the AWS Certificate Manager and certificates to lock that up, and we're going to try to get to that as well. So with that, I'm going to turn it over to Mr. Ran, and we're going to show some code. And Ran, the screen is yours.
Awesome. So let's get started. As you know, we're going to build something running on ECS. Unfortunately, not serverless, but this time I'm okay with go ahead and trying to do so. For that example, it's not written in Go. I picked Flask and Python because that's easier for me to go with rather than Go. And it's a pretty straightforward application. I mean, let's review that very quickly. The most straight out of the box Flask application, running with something super secret that we'll see soon, and listening on port 80. I'm not handling at the moment any kind of TLS or something like that, at least not at the application level. We're going to take care for it on the load balancer level. So this is what we got for the app. The Docker file also pretty straightforward. Python 3.8, working there, adding the application, installing the requirements, exposing port 80, and then running Python. This is obviously not the best recommended way to run Flask applications, but for our purpose, it's not really, we're not doing any scaling. We're not doing any things that might cause us issues over here. So this is our application. By the way, if you'd like to see it afterwards, I can upload it to any GitHub repo for you for help. But let's go ahead and start working on it. So first thing that I'm going to do is to build my Flask application. So I'm going to do it using the docker build -t Flask. Luckily, it's already built, so I'm good with that over here. Now I'm going to run it just to make sure it's running locally in a good way. So docker run -port 8080 Flask application. I'm going to run it, and hopefully if I'm getting into now to a local host at 80, so I'm getting an internal server error. We're starting left foot. Let's see what happened over here. Oh, that's good. That's a great sign why I might have issues before that. So in order to fix that, actually, I'm going to do something quick that I know what's the issue is for. So I actually missing JSON file from here, the import JSON. So I'm going to fix it. And actually, Eric, that might be my initial issue
there we go.
in the first place.
There we go.
Yeah.
Well, one of the beautiful things of
live errors.
Yeah, exactly. One of the beautiful things of live streaming is live coding live errors. This is how we fix it, folks. So now my code is perfect. Yeah. You understand that, but you know, the rest of you.
Yeah. Yeah, I'm a simple person. My code might have some issues, and here's the issues. I'm building the Docker file again. So it's going to be prepared very soon. And then we're going to run it again to verify that even before we're going into production or even deployment, we're just making sure that everything is running correctly. So I'm running it again. It listens up on the port, and let's hit again the localhost. Perfect. We're getting the super secret. Remember that we're going to get it sometimes afterwards again.
Nice. I got to tell you, I'm so excited. I feel like we're broadening our horizons when we're running Docker file builds on Happy Little APIs. This is pretty exciting.
Great. So now in order to get started with AWS and ship out our image, we're going to use the ECR, Elastic Container Registry, which allows us to push Docker files into there, so we can, use ECS to load images from there. So our first command is to create a repository. This repository will hold our image, the Docker image that we've just created. So it's pretty straightforward. AWS ECR create repository, the repo name, and I'm working on Eric's profile. So let's hit the command over here. And it's generated perfectly. Now we need to create some login credentials into that ECR. So our Docker container will be able to use it and push images into that. So again, get login is going to, in other words, create a login command for me. So as you can see, Docker login -UAWS -password in a way that I can now use it through my Docker. So all I need to do is just copy paste this command and hit the enter button, and login succeeded. Perfect. So if we'll have a look now what happened, I'm on the ECS console. I'm going to switch to the ECR repositories to see what happened over here. And I'll be able to see that I got my Flask app repository. Just to be aware, everything that's related to Flask app pre or anything that pre is my playground before that, but now I'm doing everything live on the original name Flask app. Nice. Now that we got it, we need to build the image and push it into our new ECR. So I'm going to hit the build again, just in case I've did some changes. It's running very fast, and I'm going to tag that image, Docker tag Flask app locally, the latest one, into my newly created repo on this specific account. Again, the latest one. So I'm going to tag it. That's pretty quick. And now I'm going to push that image into ECR, so it will actually live on this account.
Okay.
This may take a few moments.
I'm going to stop you there while you're doing that. So let's say, for instance, I did not understand everything you say. Okay. Now that's not true, but let's just say maybe I'm not a container expert. Can you kind of explain that in simple terms, what you just did and why you had to push something to ECR?
Okay, so in containers, it helps us to encapsulate some application into a container, something that we can run in many environments.
Okay.
So what I just did in a review of the actions, I built my image I need to take my Docker file container and convert it into an image that everyone can take and run. Now, when I'm building it, it's only living on my machine, my Mac over here.
Okay.
In order to make some other repos or other clusters to use it, I need to push it to some repo. This repo can be the Docker Hub, it can be CR, it can be something that you manage on your own. But that's the way for you to take your image into some place meaningful that everyone else can use.
Okay.
So what I did with these commands is to create a repo on AWS to get the credentials to be able to interact with this repo, and then tag the image and push it. So pretty simple. It's almost like uploading a file, but in the Docker kind of language.
All right. Thank you. I follow. I mean, I got it, but maybe others.
Yeah. While it's being uploaded, I'm going to review some dead jokes. So bear with me. It might take like a couple minutes. So did you hear about the red ship and the blue ship that collided?
I did not.
All of the sailors were marooned.
Is this the surprise application you built?
Yes, this is the surprise. It's not mine. It's somebody else.
Okay.
I wanted to build something like that, but I don't have the jokes, so I just said, let's gonna use it. It's like serverless. Somebody built it for me, so I'm just consuming it.
Now, I am a dad, so I get these jokes. I'm a dad of 5, so yeah. All right, read that one out.
Great. How did Darth Vader know what Luke Skywalker was getting for Christmas? He felt his presence.
That's nice.
And let's see how things are going. We're quarter way there.
Ooh, that's a big one.
If it will take a bit longer, I'm having an alternative, but let's wait a few more moments.
That's fine.
Why did Sherlock Holmes go to the Mexican restaurant?
He was
looking for a good case idea. Oh, that's nice.
Hang on, I'm gonna bring us back over to my screen so people can see my face. That was my what face on? That wasn't a good one. So, all right, here we go. Going back to your thing here. All right, bear with us, folks.
Perfect.
Hang on a second here.
While it's being uploaded, I'm gonna review some of the other things that we're gonna do. I'm just gonna recap them, and hopefully by the time I'm ended, we'll just be able to use that. So once that is being created, we're gonna have the image on the ECR, and now the next steps that we have is to create a task definition. Task definition takes an image and defines in what way do we want to run it. For example, will it be inside a VPC or will it be natted? Will it be what port should be exposed? What environment variables should be set? What's the runtime that we're going to choose, like ECS, plain EC2, or Fargate? So that defines the task that we're about to run. Okay. After that, we're going to create a cluster. Cluster is the highest level entity within ECS that defines a set of services that are about to run. In our case, we're going to have a single service that is going to have a single task that is going to use a single task definition. Again, everything here is pretty much basic and straightforward. That is going to define that now we're running some task on some EC2 instance, and it's going to be under a VPC. Just as you mentioned in the presentation, we're going to have everything inside a VPC because we're in a position that we can't expose anything to the outbound world. We just need everything inside the VPC.
Alrighty.
In the meantime that it's being created, I'm going to create some of these things just to cut some shorts over here.
Okay, and I'm going to interrupt you.
So
we had one submitted dad joke on the chat. It says, why did the serverless bartender, why was the serverless bartender always spilling drinks? He had no containers.
Wow.
Nicely done.
That's nice.
Nicely done. Yes, I like dad jokes. All right.
Let's see if other people can come up with some other good dad jokes.
All right, so talk to Talk to me. So we're doing 3 different types of. That's a 3, by the way. If you don't know the rules, if you've never seen me speak, when I hold up one finger, it's always what I say, not what what I show. I could do this, or I could put one toe up. It just gets weird. But talk to me about. We have 3 different types. We have NLB, ALB, and AWS Cloud Map. Now that you've used all 3, and we're going to demo those shortly, which do you think you would lean towards? And why?
So for smaller, yeah, that's a good question. I would definitely won't lean to NLB unless your application it's not an HTTP based. The main reason it's because it's just harder to maintain. It's a bit of a different approach. And honestly, if you're using a HTTP based framework, any kind of them like Spring applications, Flask, Tornado, Express. It's most straightforward to go with the ALB. The ALB, if you're not doing something very complicated, if it's a single kind of service or even very few services that has no much interaction between themselves, definitely ALB. It's much simpler. It's easier to set up. It's more, I'm not sure about the cost, but I think it's a bit more basic to work with and consume. Now, if you're doing something more complex, if your application is having, tens of services or hundreds of services or even thousands of services, it's going to be hard to maintain all these load balancers. It's going to be very painful for you to go through each and every one of them. So for that instance, I would go with Cloud Map. The main benefit of Cloud Map is that you can register once throughout the DNS or throughout some other methods of auto-discovery to register your services. And then you don't really care what's the state of the service, where is it actually running now, or what's the best way to communicate between service A and service B. The Cloud Map takes care for all of that, and that really goes hand in hand with service meshes and things like Istio and similar things. So just if your application is getting complex, you should definitely, before you jump into it, you should read about it. But that would be a better choice to pick. And actually, the 4th choice that I would recommend for everyone, just go serverless. I mean, it's easier. You don't need to provision or maintain these kind of things. There's no load balancers. There's just Lambda function, and everything is running on a happy state.
Yeah, I like that answer. That's good. There's a great breakdown. I also posted in the chat on the load balancer comparison links on what do you need, and so what makes sense to work with. I also posted a link for AWS Cloud Map, just so you know, these files, we are having some internet issues, so the files are taking a while to load up, but we're almost there. So I appreciate your patience, and I really enjoyed you kind of walking through that. I personally would probably lean towards AWS Cloud Map because I like kind of the idea of just saying Cloud Map links me to it, and it'll do some round robin as I needed. But then most of my mapping and stuff, I just kind of push all that back to HTTP API. I like that. But there's some great reasons why you might need to do an NLB or an ALB to make that work. So good breakdown on that. I appreciate that. So, all right.
I think for the meantime, we can go back and start working on our cluster. The task definition should be ready very soon. So let's just go back and continue our work.
All right, the screen is yours again.
Perfect. So we're just about to end over here, just a few megabytes, and I'm really truly sorry for that. Probably everyone today working from home, so they're consuming all the bandwidth that is possible. But our next steps is to create a task definition. I'm going to hold it for a moment. For the meantime, I'm going to create a cluster based on EC2 Linux type. So let's go into clusters. Again, I'm on the AWS console. I'm going to zoom in a bit so it will be easier. And I'm going to create a cluster. The get started is a way to do it faster, but I'm going to review the things that I'm about to define. So once I'm creating a new cluster, I can define network only. This is relevant only for Fargate, but we're not going to do this time. And EC2 Linux plus network or Windows. Obviously, we're picking Linux for this one because much simpler, much basic. That's exactly what we need for here. And we're going to the next step to create this cluster. This cluster name is going to be Flask App Main. And this is going to be on-demand instances. I'm going to choose EC2 instance type, something a bit different. Let's pick the T2, let's take extra large. And I'm going to take one instance of it. I don't need more for this scenario. And I'm going to have Amazon Linux 2. No SSH at this moment. Hopefully, I won't gonna need to log into any server. I'm going to create a new VPC. Thanks for doing all this work for me. It's almost serverless, not fully, but almost there. And one last thing is that we're going to allow inbound rule connections. Anyone can log into port 80. Once we'll finish, all of you will be able to access because it's going to be public at the end. But at this moment, we're going to define port 80. YAML, as everything suggests, and you know what? Let's just go ahead and create it. So it's being created. That should be fairly quick. And we got good news. Everything was pushed. So we're going to go ahead. Yeah, celebration that the internet is working while everybody's, watching Netflix. So while this ECS cluster is being generated, I'm going to open another tab, and we're going to create the task definition. Let's go back to the home. And let me know, give me any feedback in the meantime if I'm doing something fast or slow or, any feedback or questions, I would love to get them.
All right, yep, I'm watching.
So we're going to create a new task definition. Perfect. We're going to create a new task definition. As we mentioned, we're going to do that EC2 launch type. And let's put in, again, Flask App name, Flask App main for the task definition name. The task role is the basic one that comes out of the box. And the network mode is going to be AWS VPC. That's what we need for this scenario. Task execution role, everything as usual. Let's give it some, maybe 256 memory and 512 CPU units. That should be very enough for our Flask application. It probably won't take more than 10% of it. And let's add a container. Now it's the point that we're saying, okay, task definition, I've defined your environment, and you're going to run a specific image, a specific container that we just pushed. To get that image information, let's go again to ECS. And while it loads, so container name, it's going to be the Flask app. That's the name of the container that we're about to run. And in order to get the image URL or the image ARN to be more correct, I'm going to get into the Amazon ECR, the repositories. I'm going to get to the Flask app. And now I can see that I have an image, the latest one. This is the latest that I've pushed. The image URI. This is exactly the thing that I'm interested to copy and paste over here.
Hey,
this is the image that we're taking.
Feedback is your pace is good, so keep trucking on. So doing good, thanks.
Perfect. One last thing that I'm about to do, port mapping. Inside the image is 80. I just need to tell AWS, hey, you need to listen on port 80 because that's the connection to the outbound, and it's going to be TCP. Except for that, I don't need to change any configuration. There are lots of things to configure when we're doing a container inside the task definition, but for us, it's more simple. And I'm going to hit the create button and create this task definition as well. Now that it's created, our ECS cluster also got created. Let's view the cluster and let's go back to the list of tasks that we need to do. We've created a task definition. We've created a cluster. Now let's create a service. Service actually tells the cluster, hey, dear cluster, you have all your resources. You now need to run a specific task definition as part of a service. So we're on the service tab. Again, AWS console service tab. We're going to create a new service. This service is going to be EC2 launch type. We're going to use the Flask app main image with the latest one. Pretty standard, the name of the cluster that we're doing. And we're going to name this service the, let's call it main service. Number of tasks 1, I don't think we need anything complex at this moment. Rolling update, it means that the deployment will be straightforward. I'm not looking for any canary deployments or blue-green ones. And placement templates, everything as usual. Next step. Now we need to do something before that. Actually, let's configure a VPC. So that's the newly VPC that got created for our account, for our cluster, ends with 030. We're going to choose 2 subnets for this one. And the security group is already what we defined. We're not assigning any public IP because, again, we need this application to be encapsulated inside our cluster. Now, we're going to start, as you can see, there is the load balancing part. We're going to start with an application load balancer. And afterwards, we're going to try also the network load balancer and the cloud map. So for that point, we're going to choose a load balancer. I'm going to give the health check grace period some more time to initialize. Let's give it, a few more minutes. And now I need to choose a load balancer. As you can see, AWS really instructs me and it says that there is no current load balancer, so I need to create one. Let's click on the button and create a load balancer. Oh gosh, why it's not serverless? If it's been serverless, I'd probably end by now and, everybody was going home and, keep doing nice things, but I'm buried in this stuff. Load balancer types, application load balancer, that's what we're going to create for this example. We're going to name it main LB. It's not going to be an internet facing, it's going to be internal because we don't want to expose it. At this point, I'm going to create a listener on port 80. We're going to show afterwards how to create a TLS kind of a listener. And now I'm going to choose the VPC that we discussed about, 030. I'm going to choose the 2 AZs that it's going to be part of. And let's configure the security settings. I know it's not HTTPS yet, it's just plain simple HTTP, but let's go with that. Security group, let's create a new security group. All we need is just to listen on port 80 and, let's prepare the ground to add also a port, the HTTPS for future.
There you go.
So we got 80 and 443, configure routing. So at the moment, I'm going to create a route or a target group. So one moment before that. We're going to have a load balancer and a target group. The way it works, the load balancer listens to your request, the incoming request, and the target group is the one that is assigned to take the request from the load balancer and ship them to some targets. That's why it's called target groups.
I'm gonna throw this out. Sorry to interrupt. That's why they call it listeners. I'm just throwing that in there.
Exactly.
Yes.
Yeah.
That's all I got.
Listeners and targets. Nice one. So the targets are going to be our EC2 instances that are going to be provided by ECS. For that reason, everything that I'm going to configure now going to be pretty much irrelevant. So I'm just going to configure a temp target group because ECS is the one that should be responsible for updating the target group. So I'm just going to create one. We can call it temp. And at the moment, we're just going to say that the target group is instance, protocol HTTP 80, everything plain simple. I'm not going to register any targets because, as I mentioned, I want ECS to be responsible for the target group and manage it because that's the way the dynamics of containers work. Because if now the instance, for example, is unhealthy, I want ECS to take care and move it to another instance. So let's just hit the review and create. So once this is being created, I'm just going to go back to the load balancer section. I'm going, as I mentioned, to disconnect from the main LB, the listener, because I want, from the listeners, I'm going to remove the specific target group because I want the ECS to manage it. So I'm going to delete it. Don't worry, it's going to be configured very soon. And for the target group itself that we just created, the temp one, I'm pretty much zoomed in. Let's pull it off a bit. So for the temp one that we just created, I'm going to remove it because, again, ECS will take care for creating this for me. Now that we got a load balancer, let's go back to ECS. And let's create the target group. This is the main load balancer that we just created. Now, container to load balance. This is how I configure for ECS. Hey, take this listener that we just provided, and this is going to be the mediator to the instances that you're going to launch on. So I'm going to create a new production listener port. Again, I'm still doing it on 80 because I want it to be plain simple. Going to HTTP, and I'm going to create a target group. This is the name of the target group that ECS will manage. Let's give it another suffix over here. And the target group protocol is going to be in HTTP. As we all know, the application itself is listening on port 80. So regardless what I'm exposing, the application is HTTP and not HTTPS. Health check path is the main slash. That's what we're working on. And just one last thing that I'm turning off right now, but I really recommend reading or hearing more about is the service discovery. At the moment, we just don't need it. So let's create the service. I'm not doing any auto scaling at the moment. It's not really interesting for us now. And reviewing everything very quickly and creating the service. As we can see, the service created, the target group got created again, the listener again, and the service created. Let's see the service and let's see some things running over here. So one thing that I want to have a look again is at the load balancer. We will be able to see that our main load balancer got the listener again. And now the target group is the one that we defined with the main suffix. And it's configured properly. I'm not going to wait for it to load because I know that it's loaded properly. And let's see if we got some tasks running.
That's the kind of confidence I like to hear.
Perfect. So we got a task running. That means perfectly. Yeah. You don't know guys out there, but we just had some issues internally with probably some VPCs and initialization of ECS instances. So I'm pretty relieved to see that our ECS instance is running. So let's review what we're seeing here. I'm pretty sure not everyone is super familiar with what's a cluster, what's an ECS instance, what's a service, what's a task. First of all, you can read more about it on AWS. They're doing a good kind of description. But we got the cluster, which is the highest level entity that we got in containers. And then this cluster needs some infrastructure to run services on. And I'm putting aside Fargate because that's not a part of the talk. These EC2 instances need some correlation to ECS. So once we're deployed a cluster, it's going to create an ECS instance, which actually is an EC2 instance behind the scenes. The ECS service takes care for, making sure that it's running correctly, and we got the health check and deploying the agents and configuring everything for us so that will be run. So now we got resources for that cluster that we are able to run services on. Service defines the easiest way to say service that I'm interested to run as part of this cluster. Service can be composed with a single application. It can be composed with thousands of applications. Usually people tend to have pretty simple services. So for example, it can be a web framework or a web framework combined with Nginx or, even message queue. Usually you tend to divide between them, and that's the service. And inside the service, if I'll get into that, each service got tasks. Tasks helps us to scale up and down when we need to. So if, for example, one of the tasks is exhausted with too many requests, ECS will take care to measure this service and understand, hey, we're having a task that is about to get 90% CPU. That's the time to launch new tasks. So I'll be able to load balance between these tasks. And that's, again, why everything go hand in hand with from the listener of the load balancer all the way to the EC instance or instances in parallel that we're running.
Hey, we got a question for you. Got a question for you, Ron. One of the questions asked is, why did you not configure ELB when creating?
So ELB, it's a pretty kind of ancient and unsupported type of load balancer. If we'll go ahead and look at the load balancer, and let's say we're interested in creating an ELB, So we'll see that the classic load balancer, what used to be formerly the ELB, it's previous kind of generation that AWS does not promote anymore. So ELBs are long gone. Now it's either a network load balancer or an application load balancer. And for this one, we chose ALB. We're going to show network load balancer right afterwards.
Cool, thanks.
Perfect. And yeah, never apologize for asking.
That's right.
Great. So let's go back to my deals over here because I a bit forgot what I need to do now. We got a service, we've configured everything. Now our service is encapsulated, unfortunately. So if we'll have a look on this task that is running, it has some private IP, but it doesn't have any public IP. So it means that if I'm having some instances inside my VPC, I can log into that, but I don't have any, at least not at the moment. It means that I can't log in and show you that it's working. Okay, so let's do something to attach into that so we'll be able to see that. That's exactly where the API integrations came in handy. So I'm going to switch
the meat
from
of the
this
matter.
point to exactly.
Yeah.
We're going to jump to the API Gateways service console. And just a quick look that I'm going to do, I'm interested in looking at the target group to see whether it's configured properly. Let's see the targets. Oh, good. We got a healthy target. That's perfect.
Yay. Nice. Do it live, I always say.
So let's start. Yeah, go ahead.
No, I said do it live, I always say.
Yeah. So within API Gateway, we have a few things that we're about to configure. Let's start with the first thing, a VPC link. Before we even create a new API, we need to create the backbone that will allow us to mediate between the new API Gateway all the way to the VPC that all of our software, all of our containers is running in. So I'm going to create a new VPC link. There are two options for REST APIs or for HTTP APIs. Obviously, we're going to pick the new HTTP APIs, and we're going to name it VPC link main. I don't have any meaningful names, so if you can recommend some meaningful names for me, that would be super helpful. As you can remember, the VPC that we're working on is 030, which is great. That's exactly what we're interested in doing. We're going to attach it to both subnets. So it means that it will be able to connect to both of the subnets. And one last thing, by the way, a small bug. I'm not sure if you're seeing this, but API Gateway -object for everyone that's familiar with JS or Node in general, that's probably, yeah. Take a screenshot, Eric. I want to be rewarded for this kind of tickets.
Rand gets credit. Okay.
Great, and I'm going to choose the security group. They're pretty plain simple, just port 80, and we're going to create that VPC link.
Yep.
Now we got a VPC link that is able to mediate between API Gateway, the HTTP APIs, to our private subnet.
I'm going to jump in right here real quick if I can. Sorry to interrupt you.
Yeah.
A couple of things. So when he was creating the VPC link, you notice, like you said, we had the REST API and we had the HTTP API VPC links. The nice thing about those is those use the same technologies we use for like the VPC for Lambdas and VPCs, in that you can share that HTTP link. So if I have multiple HTTP APIs, they can all share that VPC link if they're going into the same subnet. So you don't have to create one for every HTTP API if you're going to have them all pointing at the same subnet. So something to note on that.
Yeah. Now that we're set up with the VPC link, so let's create our first HTTP API. So I'm going to do build on HTTP API. At this moment, I'm interested in adding an integration to a private resource. I'm going to zoom in so you'll be able to see that. As AWS mentions, the following integration cannot be set up during the creation. Finish it and then set it up. So I'm just going to listen to what they're saying. I'm going to cancel it over here. And again, I don't have very meaningful names, so API main would be the name of our API. Let's hit next. At the moment, I'm not configuring any routes because I can't. I'll do that later. I'm going to choose a stage name default, which is the default. And I'm not going to choose auto deploy because I want to control whenever I'm doing the deployments for that API. And now I'm just going to hit create. How are we on timing, Eric?
We have about 14 minutes, so you're doing good. And we can run over if we need to. That's okay.
Okay, so I'm gonna make it a bit faster. So now that we have the API, I'm going to define first a route. A route, it's what this API accepts to be called. So for this instance, I'm going to do any kind of operation to our main endpoint. It means that any kind of call will get accepted to our API. And I'm going to add an integration. This exact integration is what we couldn't do before, but now we can do. Yeah. Let's go back. Let's go to manage integrations. I'm going to create a new integration. And as you're familiar, I'm not going to do Lambda, although I wish I could. Not HTTP URI, but I'm going to do the private resource. And as you can see, I can configure ALB, NLB, or Cloud Map. I'm going to choose ALB. And let's pick our load balancer. It's called main LB. And the listener for this one is going to be HTTP 80. No description at the moment. You're all knowing exactly what I'm doing. And this is exactly what I'm telling the API gateway. This is your VPC link main. This is exactly what we created a few moments ago. So this tells him, in order to accept this request, go to this VPC link and forward that. Last thing that we need to do is to attach this integration into our route. So it means that everybody that is going to call my main endpoint is going to get to this integration. Sorry, I clicked on create one. I'm not going to create one because I just did. I'm going to choose this one, which is the main LB integration that we just created over here. This is the VPC link. Everything seems good. It seems like the right thing to do. And I'm going to attach the integration. So at the moment, we only left with actually deploying our new configuration. So let's deploy that. I'm going to deploy it to stage default. And hopefully,
moment of truth.
Now we'll be able to see what's going on. Yeah.
Drum roll.
In order to see what's going on, I'm going to see the stage itself and the invoke URL. That's the temp URL that we're getting for this.
And look at that.
It's working.
What? You can't see me dancing, but I'm dancing for you. Nice. Hey, let's do this, right? Let's, because the NLB looks very similar. It's literally the same setting, just pointing to a different one. Let's do Cloud Map, and then we'll come back to NLB if we can. Does that sound good?
Perfect.
All right.
Yes, perfect.
But a little more celebration that it worked. Okay, I'm done.
Yeah. I gotta tell you, I was super nervous because everything messed up just right before the presentation. And I was, oh no, you're all gonna see that nothing is actually happening. That's not good.
These guys don't know nothing.
I'm pleased.
Yeah, that's how it works.
Okay, sorry. Yeah, let's do Cloud Map now. Cloud Map, to be honest, I'm not super familiar. I just learned about this service probably a couple of weeks ago. So I'm going to be very straightforward with the AWS console has to suggest. Let's create a namespace. Namespace defines a composite of, of services or things that are going to be attached together. So I'm going to create a namespace, no meaningful name. So let's call it NS main. Or live, because I think the NS main is already taken. And we're going to do API calls and DNS queries inside of VPC. And we're going to choose our VPC 030. Let's create this namespace now. It's going to take a few moments, and let me review back my things over here. If we'll have some time, we're going to show how we're using ACM, the certificate manager, and Route 53 to make our endpoint to something that it's real URL. And we're going to do the Cloud Map now, which is great. I think the Cloud Map should be ready in a moment. You know what, on the meantime, I'm going to show how we work with ACM, Certificate Manager, to make our endpoints. Yeah, our endpoint doesn't look very nice. I can't point users to this endpoint, unfortunately. It's not very professional. So in order to do so, it's very simple. If you're having your domain listed under AWS, under the Route 53, all you have to do is just to request a certificate, a public certificate. let's request it. I'm going to do live at sleep.name. Our domain is sleep.name. Thank you, Eric, for buying this bizarre domain.
Yeah, you got it.
And I'm going to do a DNS validation. That should be very easy, confirm. So the way it works, I don't need to change anything. I don't need to jump between screens. It tells me, okay, you need to do a DNS validation. That's what you need to add. And I'm going to jump quickly, to Route 53 to configure it. I'm going to rush a bit things now because I think that we're...
don't feel rushed. We're fine on time. We can run a little over if we need to. And if you have to skip this, that's okay. So we're good.
Yeah.
Oh, your connection got closed there.
So
there you go.
Yeah, I think I might have an issue, but let's cut through the chase. I've already created one that's called test.sleep.link. And now I'm going to use this one to serve from the API gateway. To do so, I'm going to use custom domain names. And I've already created this test.sleep.link that is already approved. I've created it to be a custom domain name, and it sets up everything for me. Behind the scene, it sets up a CloudFront that is going to respond to TLS 1.2 with all of the best practices. And again, this is literally serverless. I don't need to manage certificates or anything else. And I'm just going to map this API to our HTTP API that we just created. So configure API mapping. And this is going to be to API main that we've created. It's going to be to stage default. And I'm not setting the path because it's the main one, so I don't need to configure anything. I'm going to hit save. And just to be on the safe side, I'm going to redeploy my endpoint. So let's deploy that over here. And now, one last thing that we need to do that I've already done, under Route 53, I just need to tell anyone that is going to resolve my API, where is it going to? In other words, I need to tell people in the world that test.sleep.link, it's an A record, and it's gonna get to the custom domain that I've just created. If you're doing it, it's pretty simple. AWS also tells you that this is part of a hosted zone. And now if everything works, let's get to test.sleep.link, and it works again.
All right.
So in that pretty easy steps, we just converted our website from a not very nice endpoint to something that we can share. Again, sleep.link is, I don't think that I would share it with anyone, but all of you can get access to it right now to actually see that it's working. Let's go back to our cloud map. 5-6 minutes left. Let's do it quick. So we've created the NS Live, the namespace Live. Under the namespace Live, we're going to create a service. Let's call it a Live Flask service. This is our service that's going to point out to our Slack. We're going to do DNS configuration weighted. These are things that I'm not going to really go into a deep dive in, and no health check at the moment because it's not really interesting at this time. And once we created this service, inside the service, we need to create the service instance. So in other words, what this service is going to point to when it's being requested. So register a service instance. That's going to be an IP address. The IP address that we're going to use, first of all, the service instance ID. So we're going to get into the ECS to know exactly which EC2 instance ID we got for our service. So this is the one. And I'm going to copy paste this into the EC2 instance ID over here. That's perfect. Now I'm going to tell him what's the IP address for this specific service, which is the private IP over here. And the port is going to be 80, as we all know. And let's register the service instance. Now we got this configured. Let's go back to API Gateway to choose this time under the VPC links that it will go to a cloud map and not what we did so far.
Right.
So again, I'm creating a VPC link.
You're under the integration is where you want to be. Oh, are you creating a new one? I'm sorry. Yeah. I'm sorry. I'll just be quiet and let you do your thing.
So let's name it main live VPC link. Our VPC that we're going to choose is the same one as before. And actually, you know what? I might mislead you. I don't need to create any new VPC links.
Just
you're right.
A new integration. Yep. We'll cut that out. They'll never know.
Yeah, you're right. So let's create this new integration. Under Manage Integrations, I'm going to create a new one. It's going to be a private resource. And this time, instead of an ALB, NLB, I'm going to choose Cloud Map. The namespace that we just picked is NS Live. And the service is Live Flask service. And I don't have any parameters for it now. We can add any afterwards if we need to. And the VPC link is the same one because we're going to get into the same VPC as before.
There you go.
Now we can see that we got two integrations, one load balancer and one cloud map. What we're going to tell now is, hey, so far we've integrated to the load balancer. Let's detach this integration. And instead of it, let's connect to this one, which is the cloud map. Now it means that every request will go through the cloud map service registry into our cluster. Let's deploy this and cross fingers, this should work.
Of course it'll work.
So let's hit the refresh. And yes, it works. If you don't believe me, let's open a new tab.
There it is. Yes. Celebration. All right, so we've got
amazing.
We've got 2 minutes left, so I'm going to jump in, and just so you know, NLB is much like ALB. You're pointing to the NLB instead of the ALB. It's the same setup. So I'm glad we got to show the difference between setting up a load balancer or a cloud map. Now, so what I'm going to do is I want to talk real quick. We had a question in here on why would I do this? Why do I need this? Why, if I've got ALB already working, why do I need HTTP? And that's a good question because and I got a good answer. Let's try that. The reason you want this is because there's a lot of features that are coming with HTTP API that aren't available in ALB. For instance, throttling, caching, the way authentication works, the JWT authentication. The second part of that answer is the goal for API Gateway is to bring feature parity from REST API to HTTP API. Now, I can't tell you dates and things like that, and in fact, I'm telling you some pretty good stuff right now. But that's the goal going forward, is to bring what works on REST API over to HTTP API. So if you're looking at things like service integrations, looking at things like caching, API keys, different things like that you can't do with a load balancer, you can then use HTTP API to handle that. And hopefully that helps answer. Simon is posting a workshop that walks through some of this. I appreciate that. I'm also going to post a link to a webinar that I did earlier last week that talks through some of the same stuff, but mostly it talks about what's new on HTTP API, what we're doing with it. There's a demo on AWS Cloud Map where I actually do show the filtering as well, so we can kind of cover that. And with that, I appreciate you joining us. First episode of season 2. Ren, thank you so much. You rocked. I had no doubt. I appreciate that. He's just nodding his head. There you go. Can you hear me, Rand? So yeah, and I appreciate that. And it looks like we will let Rand come back on because dad jokes are always appreciated. This was done without any Diet Dr. Pepper, just so you know, and I feel like we made it, but it was rough. So with that, we're gonna say goodbye. Rand, do you have anything you want to say before we sign off?
Just stay safe, guys. I know it's a tough time. Try to hold your, breath for, a month or two, and then everything is going to come back as usual. Yep. Be healthy, be safe. God bless. And we do this again in 2 weeks. And again, thanks to Ren. And 2 weeks, I'll see you again. We'll be talking about more API goodness on Happy Little APIs. And with that, we are out. Thank you so much.